Hi, my name is Stuart Ozer, and this is Lab 1, Charge Tapes. The purpose of this lab was to determine amount of excess charge on a piece of charge tape by hovering one charge tape above another and observing interactions with other charged and non-charged objects. The system was both pieces of tape, the surroundings was everything else. The necessary physics principles here is Coulomb's law, which is force equals k q1 q2 over d squared times d hat, where k is 9e9, Newton meters squared over Coulomb squared. Newton's second law was needed as well, that's F equals ma. And then the electric field on a point charge was needed, where E field equals k q1 over d squared d hat. The results here, the experiment did turn out to be unsuccessful for me, and this was likely due to human error or environmental conditions. I didn't actually see the tape hover at all. The tapes should have repelled each other, and in PHYS labs, they did repel each other. And then the found charge was 1.25 e negative 8 using a separation distance of 0.03 meters. And then the excess electrons was 7.8 times 10 to the 10. So for the initial conditions set up in execution, the base tape was laid on a smooth desk with two U-tapes on top. The U-tapes were then charged by quickly removing them off of the base tape. And then one was placed between two books and the other was brought near to see how they interacted. In my case, probably due to human error, they did not really interact, but they should have. Actually, one was repelled by the other, what should have happened. The distance between the tapes, once floating, would have been measured, and then excess charge was calculated. So the expectations: a piece of tape would repel due to similar charge. While not seen in my experiment, the tape would have repelled had it worked, and so they must have a similar charge. And then the tape is positively charged. Well, the tape was attracted to a negatively charged pen, so it must hold a positive charge. For the magnitude of, for the results of the calculations here, the magnitude of gravity was found to be 0.0015696 newtons. And then again, for separation distance, the tapes didn't separate in my experiment, so a placement value of 0.03 meters was used. And then a charge on tape was found to be 1.25 times 10 to the negative 8 through this formula here, and that's in coulombs. And that's the charge on a tape needed to make it hover. And then the electron deficit using that charge was 1.25 times 10 to the negative 8 over 1.6 times 10 to the negative 19, which gave 7.8 times 10 to the 10 was the electron deficit. And then atoms per tape, assuming a 1 atom thickness, was 3.4 times 10 to the 17 using this calculation. And then the ratio in electrons to atoms was 2.298 times 10 to the negative 7, or 1 over 2.298 times 10 to the 7, and that's electrons to atoms. For the code, we established a function, gravitational force, to calculate the force of gravity and make an arrow. And then we make another function, force from E, to calculate the force made from the electric field. And then we return an arrow that gives that. And so then we established some constants here. K is 999. The mass of a single piece of tape was found to be 0.00016. Gravity, the separation distance, and a scale factor, which is just used to scale arrows. And then we make our charges, and then we plug them into the functions, and we get that the necessary charge to float tape A above tape B was 1.2522 e negative 8, which is very similar to what we calculated. And the magnitude of the gravitational force would be 1.568 e negative 3, which was almost exactly what we calculated. So for the what if, the discussion, what if the electrons had positive charges and the protons had negative charges? Well, nothing would change here. The only effect of reverse charges would be a sign change. Physically, the sign of charges is arbitrary, and nothing would change in terms of what actually happens. Why is it important to handle the charged tapes as little as possible? And what happens when the charged tapes come into contact with your hands or other objects? The more you handle the charged tapes, the more charge you lose through you and into the ground. When you touch the tape or another object touches the tape, you ground the tape, causing it to turn neutral by regaining electrons. If the tape is neutral, the experiment cannot then be performed. And that is the end of my presentation. Thank you so much for listening to Lab 1 with Stuart Iser.